Okay, here we go. You see the answers there, so you'll know where to pay attention. We got 8 painters, 12 houses painted in 16 weeks. At that standard, at that rate, how long will it take 10 painters to paint 18 houses? Okay, so 8 painters times 16 weeks. And the other side, you've got 10 painters and X weeks. We don't know the time. And on the bottom, 12 and 18. So painters times weeks divided by houses equals painters times week divided by houses. You find X, its partner is 12. 12 times 10X equals 18 times 8 times 16. And you don't have to write down any of those answers. Just do it on your calculator if you want to. So do 18 times 8 times 16 divided by 12 divided by 10. Or you could have just divided it by 120. Same thing. 19.2 weeks comes out exactly to that. No need to round off. All right, $7.25 a dozen. Sales tax is 8.125. So the tax is included in here. You do not multiply 7.125 by 0.08 or anything else. You divide 7.25 because the unknown price before tax is what is multiplied by 0.08125. And we don't know that. But we do know that if you take a number and you add 8.125% of it to it, you increase it by 8.125%, the result is 108.25%. So you take the price with the tax included and divide it by 1 point, the tax rate expressed as a decimal. And you get 6.705. And I wrote the third place once again because I need to know whether it rounds up to 71 cents, and it does. The digit right after 5 doesn't make any difference. Then you subtract 671, now that you found it, from the total price, and you get 54 cents for the tax. Or you could multiply 6.71 times 0.08125, same thing. This series has an adder. If you study the number, you'll see, okay, every number is 6 more than the previous. That makes it what we call an arithmetic series. Okay, to determine the sum, you have to have the first term. Here's the sum down here. The first term plus the last term times n, which is the number of terms. But we don't know the number of terms if it's not written in sigma form. So what we got to do is use the formula to calculate the number of terms. And here it is. The last number, a sub n, minus the first number divided by d, not divided by 2, divided by d, and then plus 1. Then this morning, of course, that's 611 minus 11, that's 600, divided by 6. One of my students got the wrong answer because he said 611 minus 11 divided by 6, and his calculator did the order of operations, so it did 11 by 6 and subtracted that from 611, and that gives you a decimal number. That's not a whole number. The number of terms cannot be anything but a whole number. How many numbers are you adding? It doesn't matter if the numbers are fractions or not, but how many numbers you're adding, that's what n is. So there it's 101. So we can now plug in first term plus the last term times 101 divided by 2. We got to add those two together first. So 11 plus 611 equals times 101 divided by 2. A lot of you got that right. Number 4. The first few terms are, now you like to look at the limits here from 3 to 10. So this means replace k with 3, 4, 5, 6, 7, 8, 9, and 10. Now you don't have to write them all out. I write them out so that I can talk about the fact that this is a geometric series, because if you'll notice, the first term is 4 times 5 to the third, and the next term is 4 times 5 to the fourth. So what would you multiply 4 times 5 to the third by to get 4 times 5 to the fourth? Well, 4 times 5 to the third means 4 times 5 times 5 times 5. And if you do one more 5, if you have 4 times 5 times 5 times 5 times 5, that's the next term. And if you multiply the second term by another 5, you get the third term. And that is why it's geometric, because it has a multiplier. Now, here's a little hint. In our class, where we're only doing an introduction to series, if your k, or whatever the letter is an exponent, it better be geometric, because it's not arithmetic, and the only other one that we know about is geometric. Oh, so what do we need to know? Well, here's the formula for the sum. We don't need to know the number of terms, but just for grins, because we have it in sigma form, what is the number of numbers we're going to add if we're adding from 3 to 10? Hold up fingers or unmute or do something cool.
Can you ask that question one more time?
Yeah. How many numbers are we going to add up in this series if it goes from 3 to 10?
10.
Nope, not 10. That would be, it's 8. Who said 8?
May.
Good job. The formula for the number of terms is not look at the top number and say what it is. The formula is the top number minus the bottom number plus 1. 10 minus 3 is 7, plus 1 is 8. What's sort of missing is 1 and 2. If k went from 1 to 10, that would be 10 numbers to add. Not 9, not 10 minus 1. From 1 to 10 is 10 numbers. From 3 to 10, you're only missing 2. That's why there's 8. Okay, good. So it's geometric. You have to know the first number. No, the first number is a sub 1. The last number is a sub n. So you multiply the last number by r. The last number is, oh my God, I'm going to model that for you with my calculator because these are getting kind of big here. The last number is 4 times 5 to the 10th. And with a scientific calculator, you can do 4 times 5 raised to the 10th. Now, don't worry that this is going to say 20 to the 10th. It's not. And this doesn't mean 20 to the 10th. This means 4 times 5 to the 10th, even without the parentheses. 4 times 5 to the 10 with this notation, just a multiplication sign there. By the order of operations, the exponent will be done first. So this calculator will do 5 to the 10 and then multiply it by 4 and get 39,062,500. That needs to be multiplied by what? The multiplier, which is 5. So I'm going to say times 5. And now I'm going to subtract 500. I don't need to say equals, but I could, because it's going to multiply as soon as I hit the minus sign. Watch it. Boop, it multiplies. Because you multiply before you subtract. 500. Now don't say divided by, because if you do on a scientific, it's going to divide 500 by something. Say equals. And now divided by, and I don't think it's too much for anybody to do 5 minus 4 in your head. If you say divided by 5 minus 4, it's going to divide that by 5 and then subtract 1. Excuse me, I just said 5 minus 4. I meant 5 minus 1. 5 minus 1 is 4. So I'm recommending that you divide that by 4, which is 5 minus 1. And there is the answer, 48,828,000. And I'm going to send this to you. I'm going to make a file out of this, a PDF, and I'm going to send it to you so you can study it over the weekend. Number 5, what is the sum from k equals 3 to infinity of 4 times 1 over 5 to the k? Now that is not 1/5 to the k power, although it turns out that when you raise 1/5 to the k power or 1 over 5 to the k, you get the same thing. For example, 1 over 5 squared is 1 over 25. And parentheses 1 over 5, close parentheses squared, is also 1 over 25, but that's because the numerator is 1 and 1 times 1 is 1. If this were 2 over 5 to the k, then you'd have to be careful. It's not 2/5 to the k power. It's 2 divided by 5 to the k power if it's not a 1 there. All right, so I've written out the first few terms. And you will notice, I hope, that every number in this series multiplied by 1/5 gives you the next number. 4 times 1 over 5 to the third times 1/5 is 4 times 1 over 5 to the fourth. Oh, and that number times 1/5 is 4 times 1 over 5 to the fifth, and so on, out to infinity. So you don't have a last term. But the beauty of this is it's infinite geometric, and my R is 1/5, and it's between -1 and 1. Therefore, it's got a finite sum, and here it is. We do need to know what the first term is, because that's what a sub 1 is. So we need to expand the first term, which is 4 times 1 over 5 cubed, which is 4 over 1, because that's how we can visualize it, times 1 over, and 5 cubed is 5 times 5 times 5, which is 125. Then it's 4 times 1 over 1 times 125. And there it is. So there's the first term. So that's what I put 4 over 125 here. The denominator is 1 minus the multiplier. The multiplier is 1/5. We replace 1 with 5/5 because we need a common denominator, and we might as well use the one that's on this fraction here. This fraction's got a denominator of 5. I'm going to replace 1 with 5 over 5. That's 1. And 5 over 5 minus 1 over 5 is 4 over 5. And I divide by 4/5 by multiplying the numerator by what I get when I flip 4/5, which is 5/4. And you can multiply straight across to get 20 over 500. Or you can reduce it to 1/25. Or you can cleverly take out your calculator and just do 20 divided by 500. And don't forget to look at it, make sure it's right. And it's going to say 0.04. Really? Yeah, so that's a good answer too. 0.04 is 400ths, and 400ths is the same thing as 1/25. Somebody earlier asked me about how can you figure out what R is mathematically? I said, okay, if you have a series like this, if you think maybe it's geometric, take the second term and divide it by the first term. So the second term is 4 times 1 over 5 to the fourth. Divide that by the first term. The 4's are going to cancel out, and you're going to have 1 over 5 to the fourth times the reciprocal of 1 over 5 cubed, which is 5 cubed over 1. And that's going to be 1 times 5 to the third over 5 to the fourth times 1. And what that means is, allows us to do, you can cancel 5, 5, 5 with 3 of these 5s, and you wind up with 1 for the numerator, and you got 1 extra 5 in the denominator. And that would work if you took any number in this series, like this one, and divided it by the 1 to the left of it. I don't know, for some people, it's easier just to look at these and say, you know what? When you multiply the denominator by 5, that's the same thing as multiplying the fraction by 1/5. All right, little fraction review there. Okay, any questions?